Welcome viewers for to another section of my derivation class. And today we're going to deal on problems which are under stationary point. And stationary point function is a point where the derivative is equals to 0. It can also be called a turning point. It can also be called a turning point when the derivative sign changes from positive to negative. Let me explain more on more of our stationary point using a graph. This is a typical graph. Let's say we have a y here and we have x here, and this is a curve which moves in this manner. So this is the point where the curve is increasing. At this point here, it is positive, while at the point where it is decreasing downward, it is negative. And here is called the stationary point because this is the point where the curve is 0. It's moving or turning, or the turning point moving downward. This side also is called the stationary point. So using this graph to explain more on stationary point. So we have a problem here, which is under stationary point for more understanding. So we have this function here. The first thing we do is to find the first derivative or the function of this, and that will be 3 multiplied here. We have 3x here, and the power of minus 1, that will becomes 2. Here we have 2 times 3, that will be 6, and minus 1 here, that will become 1. And here we have 9, because this x is 1 here, that will become 1. This is constant. The constant will become 0. That will become 0. So we don't need this 0. We don't need this 0. So here, something is common here, which is 3. So 3 here, 3 here, 3 here, because we want to factorize this problem. And this will become x to the power 2 plus 2x minus 3, which is equals to 0 because we're dealing with derivative. So now let's factorize this. So if we factorize this, that will become x here, we have 1 here, we have 3 here, positive 3 and negative 3. So therefore this will become x plus 3 is equals to 0. And if 3 cross this inequality sign, that will become x is equals to minus 3. That goes with this x over here. So we have x plus 1 equals to 0. So if 1 crosses the inequality sign, that will become x is equals to minus 1, plus 1, plus 1. So now let's find a function of y when x is equals to minus 3 and when x equals to positive 1. So we have y equals to x raised to the power 3 plus 3y to the power 2 minus 9x minus 4. When x is equals to minus 3, so we're substituting this x with this x here, which is minus 3. So that will become negative 3 to the power 3 plus 3 times negative 3 to the power 2 minus 9 multiplied by negative 3, and we have 4. So here we have a negative 3 raised to the power 3, that will give us minus 27. And here we have this will turn to positive because we have 3 raised to the power minus 3 raised to the power 2. So that will become positive 27. So here this will also become positive 9 times minus 9 multiplied by minus 3. So we have positive 27 minus 4. Here we have minus 27. So automatically here it becomes 0. So y is equals to 27 minus 4. So y is equals to 23. Also, when x is equals to positive 1. So we have this function here, y equals to x to the power 3 plus 3x to the power 2 minus 9x minus 4. So we're substituting now. So we're using 1 in place of this x here. So that will become 1 to the power 3 plus 3 to the power 3 multiply 1 to the power 2 minus 9 times 1 minus 4. So here we have 1, and this is 1. 1 to the power 1 is 1. So plus 3 minus, let's multiply by this, that will still give us 9 minus 4. So this is 4 minus 9 minus 4. So 4 minus 9, that will give us minus 5 minus 4. So y becomes minus 9. Minus 9. So the stationary point of this problem becomes x and y. So the first one is when x is equals to minus 3. When x is minus 3, y is equals to 23. So that is minus 3 and 23. Also, when x is equals to positive 1, y is equals to minus 9. So that will be 1, 1 and 9. And with this we come to the end of this section. Thank you.